Hi class, let's think about the independent and dependent quantities in each situation here. So if we have a runner averaging 7 miles per hour, what do you think our independent variable is going to be? What about the dependent? Okay. In question 1, time is going to be the independent value here, and then the distance is going to depend on that time. So independent, dependent. Distance is dependent, time is independent. This would be your x or your domain. This would be your range. If you look at the number of apples is going to be independent, and then the cost is going to depend on that because we have the customer that's going to buy for $2.40 2 dozen apples, okay, or excuse me, 1 dozen $2.40, 2 dozen $4.50. So again, the cost is going to depend on the number of apples you want to buy. All right, let's look at definitions for the variable. The independent variable is going to be the variable that provides the input values for a function, and then the dependent variable is the variable that provides the output values for a function. If you need to take a minute and write those down, go ahead and pause the video. Let's move on to actually graphing some functions. Let's look at the first example here. We've got a local video store will rent you a video game for $3. It costs you $5 a month to operate your video game player. Your parents charge you for electricity. So let's calculate the total cost, and that's going to depend on how many video games you rent. So here's our function rule. Cost is going to equal 5 plus 3 times the number of video games we rent. So let's make a table of values here. I've got a little bit of an expanded form here. If we plug in 0, we're going to plug in 0, so the cost of 0 video games rented is $5 plus 3 times 0, okay, which is going to give us 5. If I rent 1 video, 5 plus 3 times 1 is going to give us 8. And then if I rent 2 video games, 2, 5 plus 3 times 2, which is 6, for a total of 11. So here are the points, okay, that I'm going to plot on my graph. I'm going to get a graph that looks like this, and notice the graph is a line. Notice how, look back up to our function rule here, notice how we have a coefficient of the variable plus then a starting value here. That's the kind of the standard format for linear relationships. Let's look at the next example and see what kind of graph we get here. So we're now asked to make a table of values for the function y equals the absolute value of x plus 2. So the first thing you're going to do is obviously make another table of values here. It's really, really important that when you've got an absolute value, you need to notice what's going to happen here after you graph it. You're going to get this V shape. It's important that you see both sides and pick points that are going to give you information on both sides of the graph, okay? This point may shift over to the left or to the right as well. It's extremely important that you're prepared for this V shape, knowing that you have an absolute value. So let's get a few numbers plotted here. Let's plug in -3. Well, we're going to take the absolute value of -3, we're going to get 3, add it to 2 for a total of 5. So the point is -3, 5, which is plotted over here. -3, 5. My graph's a little off. Let's plug in -1. So we plug in -1, the absolute value of -1 is 1, plus 2 is a total of 3. If we plug in 0, the absolute value of 0 is still 0, add 2 for 2. Plug in 1, absolute value of 1 is still 1, plus 2 is a total of 3. And then plug in 3, absolute value of 3 is 3, plus 2 is 5. So here we have the points listed. When you plot these points on your graph, your coordinate plane, you'll see how it forms a V shape. It's very important that you figure out what this, this vertex is of your absolute value. So the important note here is when you're graphing an absolute value equation, you want to make sure you're getting both the graph coming down and then going back up. You can graph these on your graphing calculator. And if you go to the graphing calculator, which I promise to get to you very, very soon, so as we go to our graphing calculator, okay, you're going to want to press the y equals button. And we're going to graph y equals the absolute value of x plus 2. In our graphing calculator, in order to graph absolute value, you're going to press the math button. From the math button, you're going to go over to the NUM, which is numbers, and you can see the first operation here under the numbers is ABS, which stands for absolute value. You're going to press that, and depending on which graphing calculator you're using, which version, 84, 83, you're going to get either a parenthesis, or in this case, the 84 pluses are awesome in that they actually show you the absolute value bars. So we're going to type in our x there for the absolute value, okay? And then you want to, if you're using an older version, like the 83, you're going to have to close that parenthesis, use a closed parenthesis, because yours are going to appear as parentheses. You're going to close that parenthesis. It will give you the words ABS with the parenthesis, and then you type in your X, and then you close that parenthesis because that's all included in the absolute value. And then you're going to finish your equation, okay? Now notice here on mine, you've got the absolute value of 2x is plus 2. Okay, so y equals the absolute value of x, close absolute value, plus 2. So now we can see here, notice right here on my graph, here's the absolute value, okay? And then actually it's not shifting. There it goes, it shifts. So we can see here the absolute value. We can see that here's a table of values. We can go in to look at the table, and we can look at different values in the table. Okay, so we can go up or down. We can see some of the negative values and how it comes. Notice how it starts to go up here and it goes up here. So this is the vertex there, is that reflection point where it's going to start going up. So that's how you graph absolute value equations on your graphing calculator. You can and should know how to do graph linear equations by just typing in something like 5x plus 3. You can see your graph of a straight line is there for you as well. Let's move on to example 3 now. Example 3, we are looking at the function of x squared plus 2. Okay, gets a little tricky. You can see here how we're going to have this U-shaped. Graph is called a parabola. Okay, it's what I call the tropical math disease, the parabola. So with this equation, we're going to square our variable or our input value. So let's look at our table. So if we square -2, that gives us a +4. 4 plus 2 is 6. If I plug in a -1, -1 times itself is +1. 1 plus 2 is 3. If I plug in a 0 here, 0 squared is still 0, plus 2 is going to give me 2. If I plug in a 1, 1 squared plus 2 is 3. And if I plug in a 2, 2 squared is 4, plus 2 is going to give me 6. So when you plot those points, and again, if you need to pause me, go ahead and do so. You're going to plot those points, and it's going to give you this U-shaped, which is called a parabola. I'm going to try to spell that here. Parabola. Okay, that's parabola. In order to graph parabolas, your graphing calculator will do these for you as well. In your y equals equation, press your y equals. Please make sure you're clearing everything out and your window settings. In this case, they've all been standard window settings. With your Windows, your standard window settings, we're now going to press X and we're going to square it. So you just press your variable button and then the little x squared button, which is kind of nice. If you didn't have that x squared button, you could use the caret symbol and press a 2. And then you're going, let's just add 3, I'm sorry, what's this problem? our problem is adding 2. So we have x squared plus 2. Let me go back and delete this number here and enter a 2. And then if I graph it, I can see the graphing calculator does a much better job of drawing this parabola shape, which is the U shape. You can see here's your table of values. You can see how it's coming down and then going back up again with that. Here's my equation again. So just to kind of review everything a little bit, you have linear relationships, have a graph that it's a straight line. Anytime you're going to have an absolute value graph, the shape is going to be a V, and there are ways to flip that over as well. Quadratics, when the x is squared, is going to have a parabola shape, which is a U. Good luck. Email me with questions, and I will see you tomorrow in class.